Isosceles triangles. So we've talked about isosceles already, but there's a few other things that we need to remember and know about them before we talk about the proofs. So isosceles triangles, how many sides do they have congruent? At least two, right? It has to have at least two. So at least two sides are congruent. Those two sides that are congruent, they have a special name. Do you remember the name of the sides that are congruent? They are legs. So we put that on your diagram. We did that when we first talked about isosceles triangles. They are the legs. Then the other side, the bottom side, it has a name. Do we remember it? It is the base. So let's put that there. Now we also learned that if any two sides are the same, what does that guarantee about the angles across from them? They are the same, and they also have a name. Those are the base angles. Okay, the two that are the same across from the legs are the base angles, and they are congruent. That's a fact about isosceles triangles. For any figure that has sides the same, the angles across will be the same. Now we knew all that. We do have the top angle. So the base angles are the bottom two that are the same. The top angle, do you remember its name? It starts with a V. Vertex angle. It's the vertex angle. That's the vertex angle. Now, we've talked about, thank you, all of those before, but now today we need to talk about the height because it's special in an isosceles triangle. In any triangle, a height has to go from a vertex down to its opposite side and create right angles. That's true about any triangle. That's where the height has to be. But for an isosceles, it will always go from the vertex angle to the base and make a right angle. So when you just arrow to the segment AD, that's our height. We're going to talk about the height because it does some things cool. All heights will make these right angles, so that's not anything peculiar to isosceles. But the height of an isosceles triangle will not only come down to the base and make right angles, but also directly in the center. So what is it doing to the base? Splitting it, bisecting it. Okay, so let's put a little note right here, try to fit this in somewhere. The height will bisect the base, making two equal pieces. That's a true fact. So it's going to create these two equal parts. BD is now congruent to DC. Now the second thing it does is it also bisects the vertex angle. So it's going to make two equal angles at the top. So it also bisects the vertex angle. Cuts it in half into two equal pieces. So it makes two congruent pieces there. And the other cool thing, so now that we've got two angles congruent up here, we've already got base angles congruent, now we've got these sides congruent. Notice how that height splits the triangle directly in half and creates two smaller triangles. Guess what's true about those triangles? They are the same. So it also creates two congruent triangles in the isosceles. So it will split it into two equal triangles. That's the cool thing what the height does. Several cool things. So our job today is going to be to prove that the two triangles created with the height is congruent. And we'll be asked to prove that these segments are congruent, that the vertex angles cut in half are congruent. So we're going to be asked to prove those things. They are certain true facts, but we're going to have to prove them with what we know how to prove triangles congruent. So it'll be similar to what we've done all along. So we've got this triangle. We're not told it's isosceles, so we can't just say, well, angle P is congruent to angle Q because it's the base angles. We don't know. They didn't tell us it's an isosceles. We're going to prove that it is. So we're going to go about it the very same as we did before. We start our table out, our organizing table, with statements on the left, reasons on the right. And this particular one wants us to prove that angle Q is congruent to angle P. And so to do that, we will have to prove the smaller two triangles are congruent to each other, because then we can say congruent parts of congruent triangles are congruent. That's going to be our route, is to prove the two smaller triangles there are congruent. Let's start. What do we always start on our statements? The given. Anything you're told, you got to start with. And your reason is always because it's given to you. So let's mark those. RP and RQ are congruent. The second thing we're told is that side RS bisects side PQ. So what's it doing to side PQ? Splitting it in half. RS is splitting PQ right in half. So we know that that is happening, but now we actually have to state it as a statement. We know what bisecting does, but now we actually have to write it. So what two segments is that telling us are congruent? Good. QS and PS are congruent. And that was just the, I forgot my given, is the definition of a segment bisector. That's what a segment bisector does. When we have a segment bisecting another one, that's the definition of a segment bisector. Okay, so we've been saying all along, in order to prove two triangles are congruent, we've got to have three congruent statements. We have two. What else could we say is congruent?
RS is
Good.
good.
Good. That one, you're going to use that over and over and over. Always look for a segment congruent to itself. When triangles are connected with the same side, you're going to probably always want to use it. What's the reason? Yes, that's the reflexive property. Anything is congruent to itself. So now we have all three things congruent. Before we can prove that angle P is congruent to angle Q, we have to prove the triangles are congruent. So if I mark my final RS, which theorem is proving our triangles are congruent? Side, side, side. So that has to come before you can say that the parts are congruent. Now you can name the first triangle however you want, but the second one you have to match corresponding parts. I said angle P first. What matches with P? Q and then RS. And you already said it, that side, side, side. Then you can finish off your proof. You always, last statement has to be what you're trying to prove. Since the triangles are congruent, then all their other parts are congruent to itself. What do we call that? CP, C, T, C. Yeah, C in between all of them. Corresponding parts of congruent triangles are congruent. And that just proved that the base angles are the same when you have an isosceles triangle. We just proved that. Let's look at the second one. Again, we don't know that it's isosceles, but we're going to prove some things about this triangle that would tell us that it's isosceles. So let's start with what we're given. This time we're given angle B is congruent to angle C. So I would mark that. Angle B is congruent to angle C. So those would be base angles. And then AD, segment AD is bisecting angle, this time angle BAC. So we got to know where angle BAC is. Is it the vertex or the base angle? It's the vertex. So we know that it's creating two equal pieces on the vertex angle. So now we actually have to say that. We know what bisecting does, but you actually have to say what it's giving you now. So when you name an angle, the vertex has to go in the middle of your name. So you can call this one BAD or DAB, it doesn't matter, but the vertex has to go in the middle. So if I say angle BAD, that's congruent to angle CAD. I would bet it would take it if you did DAC. The only thing that has to be exact is when you name the triangles. So I bet that order is not detrimental. But this time it's the definition of an angle bisector. That's what we were given, that we have an angle bisector. So that's what it tells us, that it cuts the angle into two equal parts. Okay, so we've got our two things again. What could be our third? The reflexive. Yep, BD. That one's gonna, or AD, excuse me, AD. That one is gonna show up a ton when they share a side, especially in our isosceles, because that's the height we're working with. And we're looking at a triangle cut in half. So then we do have our 3 congruent statements. That's what we need. If I mark my final piece, look at it carefully. What theorem is showing this time? Do we have 2 sides?
Oh. Wow.
Angle, side. Angle, side. Yeah, we have to go in order from one mark to the next. Yeah, the side is not between them. So it's going to be angle, side. You can name your triangles, like the first one, you can name it how you want, but then you have to match it up. I'm going to have to go CAD on my next one because I went BAD on my first one. You have to match corresponding parts on that final one. Then you can end with what you're trying to prove, because if the triangles are congruent, each of their parts are congruent, and that will prove that side AB is congruent to side AC, making it truly isosceles. Questions on that one? Okay, I think this is the final one. All right, all we're told this time is that RP is congruent, I totally spelled that wrong, to P or RQ. So we'll start with that. RP, side RP, congruent to side RQ is given. Let's mark it, RP, RQ. And the second thing I know, side RS bisects angle PRQ. Is that the base angle or a vertex angle? Yeah, it is the vertex. From P to R to Q, again, that's this guy, cutting that one in half. So now we have to say the 2 angles it creates. So Madeline, tell me a name of the angle, one of them. Tell me one of the angles it makes. If we're naming this angle, you have to put the vertex in the middle. So you have to go from P, yeah, because this angle, you have to go from one side to the point. The vertex has to go in the middle. It has to go in the middle. So P, R, S. Does that make sense to everybody? The vertex, the point, the turning point of your angle has to go in the middle of your name. So angle QRS. And that is because we were told that RS bisects the bigger one, so that's the definition of an angle. We have to choose the angle bisector. Okay, what's our last congruent statement that we need? RS congruent to RS. Especially in this type of a proof, you're going to see that all the time. Many of them do, but especially these, it will. Do we have enough to say the triangles are congruent?
Yeah.
We do. What theorem is showing?
Side angle side.
It is side angle side. So I'm going to go PRS. So when I match that, it's got to be QRS for my second triangle. And you are correct. It is side angle side, which then guarantees all the rest of the parts are congruent. So we can finish off saying angle P is actually congruent to angle Q. What's that reason? CPC, TC. Okay, so just be careful naming those angles. The vertex, the point of your angle, has to go in the center of your name. Okay, you will not be too sure how it work again, but just keep your notes handy if you need to jot